I'm Eric Boyd from Internetto. I'm the Senior Director for Strategic Projects.
Hi, this is Luca from Open Networking Lab. I am a deployment engineer.
And we're here to talk to you about a joint collaboration between Internetto and ON Lab. And you want to sort of walk us through what the goals of the collaboration are, Luca?
Yeah, absolutely. So, this is about a real deployment. A deployment on a real production network that involves 3 different continents around the world. The goal of this deployment is to let entities connected to the testbed communicate together at layer 3 without using any router in the network core. So this is super important to the ONOS community because it makes possible for us to demonstrate that ONOS can work at scale in a real network scenario. At the same time, entities like Internetto are giving us a great feedback that becomes part of our requirements for next releases of ONOS.
And Internetto is very interested in this as well for a variety of reasons. If you want to go to the next slide, Luca, we can talk about that. So Internetto is a nonprofit network provider that runs a network that spans the continental US, 15,000 route miles. We own our own dark fiber. We've got 38 layer 2 switches and about 10 routers above that. Internetto is very interested in production networking. We have to serve the needs of the R&E community, but we're also very interested in enabling innovation and advanced networking techniques like the ONOS project. And so Internetto is using some technologies it developed to create an environment where we can demonstrate ONOS on a global scale. And those technologies that we're developing allow us to do network virtualization on the Internetto backbone. So the Internetto backbone is a pure OpenFlow network. We run our own controller to offer a layer 2 service, and then we run production layer 3 service above that with an additional 10 routers. And so it would be great if we didn't need those routers, if we could just run our layer 2 service and use something like ONOS on top of it. So Internetto created the ability on our network to do network virtualization, to basically slice the network up into different virtual networks. And so ONOS is taking advantage of that capability, as we had hoped, in order to show that you can build a layer 3 network. And essentially we built a global three continent network in 2 months, layer 3 network that runs across our backbone and a couple others using the capabilities of ONOS. So do you want to talk a little bit about that?
Right, correct, Eric, and that's where we started, right? We started from the network of Internetto that provided us these great capabilities. We connected 5 universities around the country using the production network of Internetto. From there, we expanded the network through 2 international peerings, one with the South American network AM Light, the second one with the European networks of Giant and Consortium GAR.
And so the AM Light effort is also using the same software that we've developed for Internetto in partnership with Indiana University.
So these 3 continents are all connected together through a dedicated layer 2 circuits. At the top of that, we are running a layer 3 dedicated BGP session that enable entities connected in Europe, for example, to communicate with entities connected in South America going through the United States Internetto network.
So I can say a little bit about this. So this is Internetto's backbone network. The red dots represent our layer 2 switches. So we have 38 switches across the US. We deliberately picked a heterogeneous mix of multiple vendors. So half of them are Juniper MX960s, the other half are Brocade MLXC16s, and we run them in pure OpenFlow mode, OpenFlow 1.0. And so we've had the capability for about 3 years to run a production network in that environment. But one of the neat things that we've added in the last 6 months is the ability to slice it up. And so it wouldn't be feasible for ON Lab to build their own network of this scale just for experimentation, but it is feasible for us to give them a virtual network, a slice of this network, which is what we've done. So you can see how our physical network is fading away, and the result is we can create this virtual network on which we can do an exciting project like an ONOS deployment.
Right, and this is what we took from our perspective. At top of that slice given by Internetto, we ran ONOS and an SDN-IP application running on top of ONOS. So what we see from our perspective are 38 different OpenFlow switches where we connected 5 universities and we connected 2 international peerings to that. So
And from the perspective of ONOS, it feels like it's really controlling our network, and in fact it's populating our network. But the reality is we have two other controllers running in parallel with our production traffic, with Genie traffic as well.
So the same technology that was adopted on the AL2S network was adopted also on the AM Light network that basically connects all the research institutions from South America to the United States. In this particular example, we always have the physical network that has been sliced through the flow space firewall. On top of that, we run ONOS and SDN-IP, connecting 5 different research institutions. So something slightly different happened in Europe when we have another physical network, which is the GEAN network that offers us GTS, the GEAN testbed services. And so thanks to that, we had from them a slice of their testbed, and we ran ONOS on top of that. Through this service, we are able to geographically distribute different ONOS clusters all around Europe. And for now, we connected recently the first 2 universities to that.
So this is a testbed environment in Europe, whereas in the US and South America, we're doing it as a part of our production environment. But it's really good for ONOS and for us to work in these different environments and yet still be able to be stitched together. And so we were able to take all these different universities from 3 continents and build this global layer 3 service in just a couple months, thanks to the power of ONOS.
So this is the entire view, maybe a little bit more detailed and technical of what I described till now. We have at the center the network of Internetto, where we started. We have on the right the network of GEANT and GAR, and here the network created on AM Light and FIU. They are all connected through layer 2 dedicated circuits. What you see, the lines that you see here colored represent the BGP peering session with ONOS and SDN-IP. So again, the result is that entities of different networks can now talk together at layer 3 through the capabilities given by this network and ONOS.
And this is also valuable for Internetto. In addition to wanting to create a platform where exciting new network innovations like the ONOS project can happen, we would also like to explore the capability of using that as part of our production network in the future. So for instance, today in the US we have 38 layer 2 switches and another 10 routers. And the possibility exists that down the line, we might, for instance, leave the routers out, which is one of the goals that Luca articulated in the beginning of what we were talking about.
All right, the NOC of Internetto kindly give us the ability to access for this demo to the real GUI, right? So what you see are all the OpenFlow switches that are running all around the country in the real OpenFlow network of Internetto, right? And what you see connected at the border there are the real universities connected to the testbed, okay? So additionally, we have a second interface that day by day the NOC of Internetto uses to monitor the bandwidth and the quality of the links between the different institutions.
So here, for instance, you can see throughput tests that are happening between the different universities that are BGP peered with the Internetto deployment of ONOS. And you can see that some of them are still working on some configuration issues. But basically, we're passing real traffic back and forth between the different campuses, and we've created this layer 3 network in parallel to our production layer 3 network that doesn't have any routers in it, and is sort of the next step forward, taking advantage of the underlying SDN capabilities.
So as an additional proof of that things are working and that we are really peering with South America and Europe, here we have another monitor that shows us a ping flowing from Europe to South America, plus another window that shows us all the routes received from the rest of the testbed in Italy. the deployment I showed till now was made possible by ONOS and the SDN-IP application, which is an ONOS application running atop of ONOS, able to connect SDN islands to external networks via BGP. So this decreases, of course, the cost of both the CapEx and OpEx because it provides layer 3 communication without any need of using layer 3 legacy routers in the core of your network. On the other hand, this technology provides a path to migrate to SDN smoothly and easy. So let's talk a little bit about SDNIP. Imagine to have your SDN network composed by different OpenFlow switches. These switches are controlled by an ONOS cluster. The ONOS cluster is composed by different ONOS instances. Then you have different external networks, which can be either legacy networks or other SDN islands. These networks are connected to the SDN data plane through their legacy router. At the same time, we attach to the SDN network two different BGP speakers that are just connected into the SDN data plane just as the external routers. At top of ONOS, we run two instances of SDNIP that are fully connected with the BGP speakers. As soon as SDNIP starts up, it parses the configuration files that tells where all the external routers and the BGP speakers are attached to. In this way, we are able to form the BGP sessions between the external routers and the BGP speakers. As soon as the BGP sessions are established, external routers start to send BGP route advertisement to the BGP speaker, which advertise them to SDNIP. SDNIP translates this request into ONOS intents, and ONOS itself translates these ONOS intents into OpenFlow entries on the OpenFlow switches, thus enabling the communication between external networks. Okay, so to demonstrate this demo, another proof is that we're streaming this video from Brazil to Italy, and we are doing a screen share with Italy, and as you can see, the video is working just fine, it's flowing. Okay? So, thank you.